everybody. In this video, we're going to be talking about some mental math strategies you can use when adding, subtracting, multiplying, and dividing decimals. So the first thing to know is that all of the strategies that we've learned in whole numbers for doing mental math still apply when we're working with decimals. Like, for example, if we had 1 7/10 plus 3 2/10 plus 4 3/10, well, we could use the commutative property to think about this as 1 7/10 plus 4 3/10 plus 3 2/10. And then we could also use the associative property to add these two numbers together first. And the reason you might want to do that is because when you add those two numbers together, you get a whole number. Because 7/10 plus 3/10 is going to be 10/10, which is a whole. And so you'll have a whole plus another whole plus these 4 wholes. And so you'll have a total of 6 wholes plus 3.2 or 3 2/10, which means that your answer would be 9 2/10. And that would be an example of using the commutative and associative properties to help make the addition of the decimals a little bit easier. You can also use this same principle with multiplication. So like if you had 5/10 times 6 7/10 times 4, well, it would be easier if we thought about this as 0.5 times 4, because 0.5 is a half, and 1/2 times 4 is just 2. So if we thought about it as 0.5 times 4 times 6.7, well, that would just be 2 times 6.7, and 2 times 6 is 12, 2 times 7 is 14. So I would have 12 wholes and 14 tenths, but 14 tenths can be regrouped because it's 1 whole and 4 tenths. And so that would basically be my 12 wholes plus my 1 whole from the regrouping, and my 4 tenths would end up being 13 wholes and 4 tenths. And that's kind of a mental math strategy you could use with multiplication. You can also use the distributive property. Like, for example, if you have 6 times 8.5, it might be easier to think about this as 6 times 8 and then add on 6 times 0.5. Because 6 times 8 is 48, 6 times a half is going to be 3, and 48 plus 3 would end up being 51. So those are some different ways that you can use the associative, commutative, or distributive properties to make the problems easier. But you can also use our strategies, like if we have 3.76 plus 1.98, well, I could use my addition compensation strategy to take 2 hundredths from this and add them to this number. So I would think about this as 3 74 hundredths plus 2, because if I take 2 hundredths from this number and add them onto here, well, that makes it a whole number instead of a decimal, which is way easier to add. So I'd say, okay, well, 3 wholes and 74 hundredths plus 2 wholes would just be 5 wholes and 74 hundredths. You can also use the subtractive compensation method or the equal additions method. Like in this case, you might want to add 6 hundredths to both numbers. So you'd think about it as 7 38 hundredths minus 5. Because if you add 6 hundredths to 94 hundredths, that will be 100 hundredths, which makes a whole number. And that is way easier to subtract because 7 38 hundredths minus 5 wholes would just be 2 wholes and 38 hundredths. And then on this last one, this one is basically using the distributive property in reverse, because order of operations tells us that we should do the multiplication first if we were just simply solving it with order of operations. However, because both of these numbers are multiplied by 25 hundredths or 1/4, I could think about this as being 25 hundredths times 17 plus 23. So it's almost kind of like the opposite of this example. And the reason this would be useful is because 17 plus 23 is 40, and 1/4 of 40 is just the number 10. And so it would be way easier to find 1/4 of 40 versus trying to find 1/4 of the 17 and the 23 separately and then adding them together. So these are some examples of how you can use all the strategies we've learned about in the past to help you multiply and add and subtract decimals. And then we also have some new strategies where you can think of the decimals as their fraction equivalents. So I kind of did this a little bit on the last slide where I would say like 0.5 is the same thing as a half, or 0.25 is the same thing as a fourth. But if you think about the decimals in their fraction versions, it can be really helpful whenever you're multiplying or dividing by decimals. It's not very helpful with addition and subtraction because addition and subtraction of fractions requires common denominators, and that doesn't always happen. But with multiplying or dividing, it can be a lot easier. Like, for example, if we think about 68 times 5/10 as being 68 times the reduced version of 5/10, which is 1/2. Well, 1/2 of 68 is just 34. And so that's a lot easier than trying to figure out what 68 times 5 is and then moving the decimal over and all of those steps. Same thing with this next one. If I think about 0.25 as being the fraction 1/4 times 48, well, 48 divided by 4 is just 12. And so 1/4 times 48 would equal 12. Because remember, you can rearrange the order of the multiplication in the numerator or the denominator. So kind of my thought process here was that I was going to get 1 times 48 over 4 times, technically 48 can be written as 48 over 1. But if I rearrange this and think about this as 1 over 1 times 48 over 4, and so that's technically the thought process I went through when I said 48 divided by 4 equals 12. Then we could do the same thing with 0.2. So if we think about 0.2, well, that's 2/10. And 2/10 can be reduced to 1/5. And 1/5 times 375, well, I know that 375 is divisible by 5. And if I think about what that would be, well, I can't split 3 hundreds into 5 groups. But if I had 37 tens, I could split it up into 5 groups, and that would put 7 tens in each group. And I'd have 2 tens left over plus my 5 ones, so that would be 25 ones. And if I split those 25 ones into 5 groups, that would give me 5 in each group. So 375 divided by 5 would equal 75. On this next one, if I have 0.05 times 280, well, 5 hundredths can be written as 5 over 100, but since they both have a 5 in common, I could divide the top and bottom by 5, which would give me 1/20th. So I'd think about this as 1/20th times 280. And if I think about this as 280 over 20, well, since they both end in 0, they're both divisible by 10, which would give me 28 over 2. And 28 divided by 2 just equals 14. And so by thinking about 0.05 as being a fraction, it made the solving process a lot easier. Now, you can also use this when you're dividing. So if I have 127.9 divided by 10, well, whenever you divide by 10, it basically shifts all the place values over 1. Because if I have 100 divided by 10, well, that's just going to be a 10. If I have 2 tens divided by 10, well, that's going to be 2 ones. And those will be my whole numbers, because if I have 7 ones and I divide them up into 10 pieces, well, I'll have 7 tenths. If I have 9 tenths and I split those up into 10 pieces, then that would be 9 hundredths. And so whenever you multiply by 10, you move the decimal over to the right because each place value got 10 times bigger. But if you are dividing by 10, then you move the decimal over to the left because all of the place values got 10 times smaller. So if we wanted to do something like 0.53 divided by 10 to the 4th, well, that means that it's going to shift over 4 place values. So I'll still have the number 5 and the number 3, but instead of having the number 5 right next to the decimal point, it's going to be 4 decimal spaces away, because every time that I divided by 10, it moved the decimal place over once and made my place values smaller. And so that's a trick that you can use whenever you're multiplying or dividing by tens. And you can also think about this in fraction form, because if I have 127 and 9/10 divided by 10, well, I could think about that in improper fraction form, where I'd have 1,209 tenths divided by 10. Well, with the division of fractions, you use the zigzag method or multiply by the reciprocal, and you'd get 1,279 over 10 times 10, which would be 100. And again, notice that that basically just shifted the place value over once from our original number. And the next thing I want to talk about is how to round decimals. So remember, the idea of rounding is estimating what numbers it's close to within a certain place value. So for example, if I wanted to round this number to the nearest tenth, well, if I look at the tenths place value and I say, okay, well, what tenths is this number close to? Well, I know that it's in between 98 and 3/10 and 98 and 4/10. So the question is which one is it closer to? And you can imagine this on a number line. So if you have a number line with these 2 tenths, well, based on the fact that the next number is a 5, that tells me that it's going to be like, here's the halfway mark. So this would be 98.35. And since I have 98.356187, it's going to be a little bit after that. And so because it's a little bit after the halfway mark, that means that I would round this number up to the nearest tenth, and my answer would be 98.4, or 98 and 4/10. But if I wanted to round it to the nearest hundredth, then I would have different numbers that I'd be comparing it to, because if I look at the hundredths place value, well, that tells me that this number is between 98.35 and 98.36, because that's the 200th values that I'm looking at. And so I'd say, okay, well, based on my next number, which in this case is a 6, that tells me that the decimal they gave me is a little bit past the halfway mark, because the halfway mark is at like the 5, because this halfway mark would be 98.355. And so that tells me that in this case, I'm going to round up as well. And you can draw out the number lines for all of them, or you can just look at what the next number is. So like if I wanted to round to the nearest thousandth, I'd say, okay, well, my two numbers that it's in between would be 98.356 and 98.357. And because the next number is a 1, that tells me that it's going to be on the smaller side of the halfway mark. And so I would round it down to the number 98 and 356 thousandths. So why don't you guys go ahead and try the last two? Pause this video and then restart it to see what the correct answer is. All right, so on part D, the correct answer is 98 and 3,562 ten thousandths, because if we look at the 10 thousandths place value, the number that's after it is bigger than the halfway mark, which is at 5. And so that means that we'll round the 10 thousandths place up to a 2, because the two 10 thousandths places that's closest to is 98.3561 and 98.3562. But since it was followed by an 8, that means it's above the halfway mark. And if you ever have a decimal that's exactly on the halfway mark, then you just round it up. And then on this last one, we're trying to round it to the nearest 10. So if we look at the tens place value, well, that's a 9. And so that tells us that this number is between 90 and 100. And since the number that follows the 9 is over the halfway mark, then that means that we would round it up to 100. And so that's how you would do those two questions. And then the last thing I wanted to mention is that you can use the same estimation techniques that we used for whole numbers to help you understand if your work that you've done with decimals is reasonable. And when you teach this to students, it can really help them, because especially with decimals, it's very common to mix up the place values. And so even if they just have really broad estimations, it can help them catch their mistakes if they make a mistake that has to do with place values. So just a reminder, the way that the range estimation technique works is you find the lower estimate. So like in this case, I would do 1 plus 4 plus 8, because that's all of these decimal values rounded down to the nearest whole number, and that would equal 13. And then you also do the upper end of the range, so you do 2 plus 5 plus 9, and if you add those together, that's 16. And so that tells us that when you add these decimals together, your answer should be between 13 wholes and 16 wholes. The front end estimation is when you just look at the first place value. So in this case, it's basically the same as the bottom part of the range. So you do 1 plus 4 plus 8 equals 13. And you can also do it with adjustment and say, okay, well, that's what all the whole numbers added together are. If I estimate what all of the parts that got rounded off would be if you added them together, you might say, okay, well, 78 cents plus 36 cents is going to be a little bit more than $1, and $1 plus 57 cents is going to be a little bit more than $1.50. And so a more precise estimation might be to say that it's going to be a little bit more than $14.50. And then you could go through and actually do the calculation to find the precise answer. But if you got some number that was like in the 20s or something like that, then the range and front end estimations would let you know that there's probably something wrong with the way that you solved the problem. And then the last method is the rounding method, and you can decide to round to whatever place value you think would work well for the problem you're given. So the more place values you round to, the more precise your estimation will be. So I could round to the nearest whole number. So like in this case, $1.57 is closest to $2, and $4.36 is closest to $4, and $8.78 is closer to $9. And if I add all of that together, that gives me the number 15. You could also, though, round to the nearest tenth, and you could say, well, $1.57 is about $1.60. $4.36 is closest to $4.40. $8.78 is closest to $8.80. And this one's going to give you a more precise answer. And if you do $1.60 plus $4.40, that's going to be $6, because 60 cents plus 40 cents gives you a whole dollar, plus the other whole dollar and the 4 whole dollars would be $6. And then $6 plus $8.80 would be $14.80. And notice that these estimates are actually pretty close to each other. So if you were to actually go through and add these decimals together, it looks like your answer would be about $14 to $15, somewhere in that range. But even if you have a broader estimation, like the range estimation, which says the answer should be between 13 and 16, it's still going to be very helpful for your students, because one of the most common mistakes that are made with decimal calculations are mistakes that have to do with getting the place values mixed up. So that's how you can use estimation techniques to check your work with decimals. And if you have any questions, let me know.